There was a demand for providing some overview and background on the various subsystems, and topology was one of those. And since that's kind of a foundational component of the µONOS architecture, I figured we would start with that. And so the idea is just to provide some overview of some of the concepts, look at the API, and provide some examples, usages of the API, and talk a little bit about the implementation and the project structure. So the topology subsystem, it's first of all, it's a little bit different from ONOS Classic in a sense that it's based on a generic scheme of entity relation thing. It's heavily inspired by, this approach is heavily inspired by Google's MALT paper, which stands for multi-abstraction layer topology or something along those lines. And in the process of doing that, one of the reasons to base it on a generic ER scheme is kind of twofold here. Is to overcome some of the ONOS Classic topology limitations. Because with ONOS Classic, the graph was basically, the representation was a pure graph, where the devices were the vertices, the links were the edges, and it was kind of almost a naive representation, which presented some problems for path computation. While it was able to do path computations, the results that it would come up with wouldn't necessarily be realistic in a sense, where, for example, for optical devices, just because you can egress on one port doesn't mean you can, I mean, you can ingress on one port doesn't mean you can egress on any old port, right? So, so this is like one of the examples for why we wanted to structure things differently so that we would be able to capture more fine-grained topology details. It's also intended to capture not just data plane, but also control plane structure and other management plane information as well.
So the relation in this case is port to port, not device to device. Because in ONOS, in the graph, the device is where the vertex is.
Yeah, so just a specific example of ONOS Classic, the link was a pair, a directed pair between two connection points, and connection point is a device port.
Yeah.
Right. And so that was kind of the attachment, the port itself is the attachment on a device, but we haven't figured out, actually, we haven't needed to, because we're not currently representing the traditional SDN topology. We have not dealt with that. But the idea here is, for example, we could create a structure where we actually have a device that relates to various interface cards, which may have their various ports, and then there is relationships between those ports and other ports. So it's probably going to be more structured. It'll probably be slower to navigate, but it'll also be more accurate with respect to modeling the network, real network. So the idea was that this is more flexible, and we don't necessarily need to come up with a full scheme up front. We can come up with a scheme as we encounter the problems. But it's important to define a schema. It was one of the lessons from the Google and recommendations from the discussions with Jeff Mogul from Google, was saying it's very, very important to pay attention to the schema as you define the schema. And we'll talk more about that later, what the schema looks like actually. It's also intended, and speaking about schema, this is designed to hold structured application-specific data. So applications can bring their own sort of pieces of information and attach them to the topology objects. And finally, it's designed, with gRPC, simple gRPC CRUD API, which also has the ability to watch events as the topology changes. This is important, clearly, to be able to have an efficient implementation of the system. Because it's based on gRPC API, clearly the performance will be slightly different. The characteristics will be different than what was with ONOS API, which was basically just a Java API. So the topology objects themselves can be, there's a core object. It can have one of the following three types. An entity can be an entity, relation, or kind. The kind of represents a class of entities or relations. Think of it as literally like a class, right? Except it doesn't come with any behavior. It comes with maybe some default data with it, but that's about it. Entity itself is a node in the graph. Relation is a direct edge in the graph. And the relation is between two entities, and entity itself is something that represents a thing of some sort of, like I said, device, interface card, port, software component, or even an application.
Mm-hmm. But so both entity and relation can have a kind.
Exactly.
Will have a kind.
Correct. Yes. And this is purely for just kind of abstract mechanism for aggregation.
You can actually create like the kinds on the fly.
Yeah. Mm-hmm. Yeah.
So and application uses for their own stuff.
And they're strictly not necessary, although highly recommended. Because you can have a kindless,
not so kind.
Unkind relations and entities. Yes. Now, all of the topology objects have an internally assigned UUID. The system generates this. The client has no control over this. It has externally assigned ID. This is something that the application has to assign. It has to be unique across all object types. So if you have a foo ID, that better be unique. Otherwise, actually, you won't be able to create it. The API will prevent you to create another one. But there's no prescribed structure for it. The system doesn't prescribe structure. We do have a convention for those IDs, but we don't have a prescribed structure.
So it's a string?
It's a string, correct. Also, each object also has a revision, and this is monotonically increasing revision. It's used for guaranteeing consistent updates and also to for optimistic locking scenarios. Now, aspects is the extension mechanism. That's where the data is, where it's basically a type value map, where the value itself is structured piece of information. And the type itself is just a type URL, it's a string. Similar to what a lot of Kubernetes resources have, there we also support labels, which is a name value map of strings, basically, and it's purely just for classification of entities and easy filtering. So you could have, let's say, have code equals production versus test or something like that. And now again, we already talked about the kind. It's just a kind of a symbolic binding to a common group of things, of like things. But it's not necessary, but it's primarily used for query today. But the idea is that in the future, it would also be used for schema validation.
So in a kind, you can, ideally in the future, you'll be able to define which aspects are assignable.
Exactly. That's exactly right. Yes. Or which ones are mandatory.
Mm-hmm.
Right? Yeah. Precisely. And make sure that they're correctly structured. The gRPC API is very simple. This is basically what it is. I'll remove the comments, but it's CRUD with a watch. Now, the create, get, update, and delete operate all on single object. So there's no mass creation. You just have to do one object at a time. List obviously returns a result. Now, for simplicity, currently list results just an array of objects that match the specified filters. So it doesn't really scale that well. But we also have a watch mechanism, which basically returns a stream of events. It's not object, but stream of events that contains objects that are described by what happened to them. Then we do have a replay option, which returns an event of none, which basically means this thing existed before you asked, and here it is, because you asked for it. And then but then it'll then hang around until you cancel the context, then you can start receiving information about which objects, what happened to them, updates, creates, deletes, things like that.
So I think the watch is for multiple objects. So you watch a collection of objects.
You can watch an entire collection. If you don't specify any filters, you'll get everything. Or you can specify filters and I'll talk more about the filter mechanism to be able to narrow down the results only to things that are relevant to you.
Okay, but you request events either for the linked or for the
for anything, for any objects. It can be.
Yeah, but you never get them mixed.
You can.
You can.
Object is an object.
Okay.
Any object has a type, and then it is a structure. Okay, so we'll talk more about these things right now. Now, one enhancement I think would like to add fairly quickly would be also currently we have an option to replay, which means I don't want only the future stuff, I also want the existing stuff. But I would also like the converse of this. I would also like saying I would only like the existing stuff and I don't care about the future events. So basically it's like a short lived, it's a replacement for list, but it's something that is more scalable.
Yeah, I kind of think we should combine these two into like just one list call that has a streaming response.
Yeah, we can certainly do that.
Yeah.
The list was initially provided for, for
standing for the seal.
Yeah, well, it's just because simple use, right? Yeah. But as you'll see, the watch itself is really not all that complicated either. So yeah, we can probably combine it and simplify the API even further.
Yeah, one other detail about the API, these CRUD operations. The API has built into it like concurrency controlled mechanisms, which is it has support for optimistic locking. So inside of each of the objects is assigned a version or a revision number.
Yep.
Which when you like read an object and then update it, the optimistic locking ensures that there was no other concurrent change on the same object, so that services operating on the same objects don't overwrite each other's updates.
Okay, so it's up to the client to bump the revision before sending the request.
No. The revision gets bumped on the far side. You receive an object, you update it everywhere else. You don't touch the revision. You send it in, and if somebody else snuck in and updated things before you did, you'll get back a rejection. You then have to refetch the object and then re-update it and retry. Did I capture that correctly, Jordan? Probably driving, so he's muted. But yeah, that's absolutely correct. And so this is we've already talked about the objects, what every object has, but this is the actual schema here. I took out some of the go-go annotations, but this is the actual Perlabuf schema. UID ID revision. It's for every object has that. Then there's the type itself. It's just basically tag of how we should be able to look at the object. And then it's one of entity, relation, or kind. All of them have basically a set of aspects. It's strictly speaking map, but it's really a set of type values. And then is a map of string labels. Then entity itself, it has a kind ID to which kind it belongs. It's just a symbolic link, effectively. And it has we provide, this is something that's a read only. We provide also an array of relations that this object is a target of and a source of. This is not something that's a read only variable. If you modify it, send it in, it's gonna get overwritten. It's not completely. And it's provided actually just for acceleration. So you kind of have to get, because we have a cache on the implementation side, and this was a very cheap way of basically giving the user more information about how entangled this object is with other things. Now, these are purely just IDs of the relations. There's more efficient, you could go iterate over this ID and retrieve all those relations, but there's more efficient ways. There's a relation filter that allows you to navigate relations better and do queries better. So an entity has that, a relation also has a kind ID, and but conversely, each relation has a source and target ID of the relation that basically defines the nature of it, right? Kind, as you see, is just a name. That's it. It's a friendly name, and that's all it is. All the other data. So say, where's all the data? That's relevant, right? That's any aspects. Yeah. Okay. So the aspects basically provide that's a primary mechanism for attaching domain application specific data to any topology object. It's a structure. It's defined by a gRPC, and it's stored as its JSON representation on a backend. Now, what this allows, this particular approach allows onos-topo to remain completely agnostic of those types while storing them, and then the applications can bring their own, as long as they know how to encode, decode them, because the representation is in a kind of type agnostic form, the JSON. The aspects are, like I said, they're keyed by their, again, it could be any string, but the convention and the API enforces that convention is a type URL. So for example, we have a location defined, which is a longitude, latitude, and some extra stuff. And so you can just create one, attach, fill it in, and then attach it to the object and update the object or create it. The idea is for aspects, just because of design kind of convention, they should be kind of as orthogonal as possible. They should be related, kind of single purpose. You should, you know, let's say we have an E2 cell, we shouldn't shove everything else possible that we want in the E2 cell. It should be really literally just stuff that defines the minimum E2 cell stuff. And things, let's say, that are extraneous, things like where this cell is located or what coverage it has, should be separate aspects, so that we can combine them. It could be, think of them, these as basically as data mixins, if you're familiar with the mixin concept. And this way, if they're designed this way, they can also be applied to different kinds or different types of objects, because you can actually have relations and entities can have the same aspect too, whenever relevant, yeah.
And does the URL as a meaning that is used in the code to navigate and get those data, or is just to...
the URL is just basically how would you it's gRPC type URL, so it's like in a local context. So literally onos-topo location string will refer to this message.
That's the pack. It's the fully qualified message name, which is the package and type name.
Yeah.
The API is fairly simple. It's on a topology object itself. So for example, to set an aspect, you would just create, let's say, a topo location, assign it the values, and then call cell aspect. And now you have it. Now the object has it. Obviously, now you need to do something with it. You would then update it or create the entity itself. But this is just some examples. To retrieve it again, you have to define aspect to put the information to kind of unmarshal it, right? Mm-hmm. So you would create the coverage in here and then say get aspect on a cell and give it the coverage pointer, and then it'll get this unmarshaled into that. You can also iterate over all these device aspects if you want to do some things to it. So it's a very simple iteration. And CLI does those things because CLI is kind of agnostic of the types themselves. Here's just some examples of aspects that we have currently in the code. This is not an exhaustive list because more were added. Don't need to go over those in detail. Let's talk about filters, which is basically a mechanism for being able to narrowing down the results and also speeding up the queries themselves for list and watch. We currently have a type filter. So you can, for example, say I would like only either entity, relation, or kind, matching this specific this type. Then you can also have a kind filter. You're going to have a labels filter. Now, type, kind, and labels filter can be combined in you can have an equals, not equals, or inset and not inset type operations. You can, and I'll show you examples of API how those can be constructed. So you can kind of perform logical aggregations and negations on those things. Relation filter is kind of a special purpose filter, which allows you to specify an entity ID and then retrieve and relationship kind. And this query will give you all of the target entities related to this given source via those relations. Now, there's a few other kind of scoping operations you can do. You can say, I not only want the target entities, but I actually would like the source entity too. I would also like all of the relations that actually lead to those things. And obviously the target objects. So you can specify kind of different combinations of these, of the scope, but you can further then narrow down the target entities to be of specific kind also. And then you can also filter the target entities by saying they must have these sets of aspects defined. Otherwise, I don't care about it. So I think this is quite helpful. I mean, we can always add more filters. Also, there is ability to, you can also specify sorting criteria for how would you like to have it unordered, ordered, or ascending. I think right now it's by type IDs only. Sorting is by type IDs, just so that you can get sort of deterministic results if you want. So I think that's it on the filters. Sorry. Yeah. Any questions so far? Okay. So on a backend, the topology store is using atomics distributed map primitive. It's all strong. Actually, I'm not sure why I just say delete doesn't either. All of the operations have strong consistency semantics, meaning like Jordan pointed out, the revision used to make sure that the updates are done in sequential order. Also, with the internal UID is used to mitigate reincarnations. So, for example, if you delete an object and recreate it, you can actually distinguish that this is a different object because it'll have different UID. But the system itself does have a cache to be able to provide some of the relationship queries efficiently. But the cache is volatile in the sense that it can be easily reconstituted on startup. So the system can be thought of as stateless. Fundamentally, all of the state and persistence and guarantees are enforced and deferred to atomics. And so the idea is that it can be deployed in a horizontally scalable manner and also upgradable gradually without basically any outage. But there's a but. We still need to test it in the multi-port configuration. And we still need to test the upgrade process, but it's designed to be that. Performance, we don't have really any data on performance at this point in time specifically to this, but I have very little reason to believe that we wouldn't be able to optimize it to operate very fast because it's just based on atomics, and atomics is fast. We simply haven't taken time to measure it. So the project structure just follows the same pattern as all the other µONOS components. In a sense, we have one main program in CMD that starts up the whole thing, then a bunch of packages under the package tree. Principally, we have the store that implements the store abstraction and also implements the object cache. Then we have a very small northbound, which just implements the northbound API, and then we have a manager, which is kind of the main entry point for the small main program to orchestrate all of this, to create the store, start up the northbound server, register the service, and managed lifecycle. It's very, very simple. It's actually not that much code in onos topology. And we have a test tree that contains the integration tests for Helmet. And I think that just tests some of the fundamentals. I think we probably add more, but right now at least there are some. Okay, there's a topology operator. It's a separate thing, but the operator provides custom resource definitions for entity, relation, and kind. And so this the data can be injected, basically defined via YAML, and then YAML file, we can inject them via Kubernetes and Helm. So we can, for example, pre-populate the kinds that we expect to have in the system by just leaving some YAML files in it.
Yeah, but then I assume this is not the suggested way to operate on the data. It's more of a setup /
It's more of a setup injection of initial sets of data. Yes.
Yeah, exactly. I think mostly it would be used for like yeah, like Thomas said, for the kind, and then when we support schema validation, it'd be nice to be able to define your schema in your Helm chart or whatever. But yeah, or maybe like test data in your Helm chart or whatever. But yeah, most of the interaction is still done via the gRPC API.
Yeah, I can see why it's beneficial to bring it up that already knows the kind and the schema and everything, but then you populate the data.
Right. I mean, it's technically possible also that, let's say, an operator like Deutsche Telekom has known assets, let's say, for cells, right? And they have information about their geolocation and other stuff like that. Things that, let's say, we otherwise wouldn't be able to obtain by talking to the environment itself. So it's information about the environment that's known a priori that could be basically used to inject the information about the cells upfront.
John, were you saying that the ROC uses this to set up its?
Yeah, it does, Ray. Yeah, so the SD core adapter there really is the device, and you know, that's something that we always want to have configured. So we use this topology operator with a YAML file to populate the SD core adapter into onos-topo.
That's great.
Yeah. So it's kind of for those a priori and reasonably static pieces of data.
Because I guess the SD core adapter is represented as a type, as a kind, sorry.
Both a kind and an entity.
An entity, yeah,
okay.
I was gonna say. Because it's actual instance of an agent that you can talk to, right?
Yep,
It is, yeah.
Yeah, but so you have one SD core adapter per core, yeah.
Actually, it's one per amp. So there could be multiple ACCs under a single SD core adapter, though I don't think we've ever configured it that way. We've never had more than one ACC. Is that true? No, that's not true, because we've got well, maybe that is true, because production still just has one ACC for the whole thing, I think.
Right. Yeah, we were talking about disaggregating that a little bit. We were talking about an SD core adapter per enterprise, but then there was a decision made that, you know, when we're deploying things in the next while, at least, we should be using an amp per enterprise, or well, an ether per enterprise, really. You know, so I suppose it's kind of a moot point whether you have an enterprise per SD core adapter or not. I hope I'm not talking in riddles there.
No, we've changed our mind often enough. It's hard to remember what our decision point is. But I think, yeah, it's, you know, pretty much either per enterprise for, you know, enterprises that are like real customers, whereas Pronto is still modeled as, you know, Pronto, Menlo, and Tucson are still 8 enterprises within one amp. So, I mean, we could go to SD core adapter per enterprise in that sort of Pronto case, but I don't know. I don't know what benefit it gets us. I think the whole idea was to get isolation between the customers, and we're giving them pretty much entirely separate ethers at this point. So they've got isolation all the way down.
Okay, so anyway, so that's topology operator. Let's go through just to show you some examples of the API in Golang. And it's fairly straightforward in the sense you can create a topo client and you know, the context, obviously, for the operation. Then you create the object, you assign it the ID, the type. Then you have to obviously create the appropriate type inside of it. In this case, we're creating an entity, which we're binding to the E2 cell kind. Then we set some aspects like geolocation, the coverage of the cell, and then the cell specific information as well, like number of antennas and PCI and things like that. And then we go ahead and create the object, you know, by shoving the create request and sending it out. And the response itself will contain the object itself after the creation operation or any error messages.
Yeah, and Yeah, so that response that contains the object, also the purpose of that is because it also contains the revision that's assigned to it by atomics.
Yeah.
And so then if you want to update it, then you can modify that object and send it in the update RPC. And if some other process already modified it, it'll reject it, which just forces you to read the updated state of the object before you modify it.
Yep. Very similar thing for an update. The idea here is that you have, unless you already have an object which you feel is up to date through process like what Jordan described, you have to get it at some point in time so that you can have a, it's like git clone, right, or git rebase, right? And then if you got it okay, then you can set some aspect and apply some new information to it, either updating the aspect itself or reapplying a whole new one. And then there's really no distinction between updating and reapplying. You always have to reapply the aspect in its entirety. And then you call update. And as Jordan said, if somebody snuck an update in there, then you would get an issue. A list.
Actually, by the way, the API uses proper gRPC error codes and everything. So that's something you have to watch out for. Like if there is like an optimistic lock failure, it'll return, I don't remember, some kind of conflict error if you try to create something that already exists or return already exists error. So it uses the HTTP error codes as they're intended to be used. So.
Yep, it's great. And Jordan performed cleanup on those things recently too.
Yeah, that's amazing to have coming from Volta. We have to dig out nested error.
Here's an example of a list with a filter. The specific is a kind filter, so I'm very interested only in certain kinds of things. So here we basically, but we're not interested in one kind, we are interested in E2 nodes and E2 cells. So we basically produce an in filter, which is in set filter, by giving it an array of kinds and then shoving that into the list request. And in this particular case, we would like to have them sorted in ascending order based on the ID. Another example of a list using a relation filter. Here, let's say we want to have a relation filter from a specific node ID that traverses to targets using the contains relationship. So in this case, it would be node. So we are going to get the cells. But we don't necessarily, here we could filter by kind also, but by the target kind, but we're not doing that. Instead, we're saying, you know what, we really don't care what kind it is, as long as it is the E2 cell aspect defined, that's all we care about. And also has to have coverage, because we want to operate on coverage. So that's kind of how you would define a relation filter. And just given an object, given the node ID, you can get all of the cells really easily. And the performance of this is, it's not ON in a sense that it doesn't have to traverse all of the objects that are in a topology. It's really a function of the N is in a relation, how entangled the object is. So it only iterates over the relations of the leading out of that object. So it's fast.
So Thomas, I'm remembering now something. When I was doing integration testing for the E2T stuff, there was a notion of sources and targets in some of these things. That was the relation.
Correct.
And that's actually encoded in the relation. The relation object defines it as a source and a destination. So it's like a bridge between two entities.
Right.
Basically.
Yes, right here. If you look at on this side of the screen.
Here it is. Okay.
That's exactly it. I mean, that's the definition of the relation. Is a what entity I'm relating to what other entity.
And the relation is always a one-to-one.
So it's a directed relation.
Okay.
Source and target are different.
Yeah, but it's always one-to-one, not one-to-many.
Correct, one-to-one. If you want to have one-to-many, then you have multiple relations.
Yeah.
Okay.
Totally fine with that.
Yeah, absolutely. Yeah. Okay.
So I had a question on that code, but
which code? Which code?
The list example.
The list, yes, right here.
So in the first filter, you're passing a filter by passing directly the gRPC messages in the in-filter values.
Yeah.
While in the aspect, we still get similar proto reference. I guess in the last line, we filter by aspect, and we have onos.topo.e2cell.
Yeah, that's a type URL string.
Yeah, but it is pointing to the topo.e2cell object, or
yeah, it's a type URL for onos. Yeah, so in a code, let's say let's say look at the coverage in here, right? Onos-topo coverage. That's a type URL for an entity that I don't know if I'm in here. If I have an example in aspects where we would be, yeah, like I would be able to create it like this onos coverage. Okay, that answers your question.
Yeah, I was just a little confused because the typing is different between the topo E2cell all capital letters on top and the one on the bottom.
And where?
This is E2cell capital.
Sorry. So okay. So these are just defined. The E2cell is a define for a kind. The kind itself is a kind. ID is a string.
Yeah.
And so we have defines for those strings in the top for some of them, like for controls and contains. We have defines for those things. For some.
It's an enum.
Yeah, but we could put a string in there if you wanted.
Oh, okay.
It's just a string. It's just a string.
Cool.
Perfect. And basically,
and the string will probably be onos.topo E2cell or something similar.
Yeah, we just have it defined like that. Yeah. Okay. Okay. Sorry, I misunderstood your original question. So I think that's it for the examples of the API. We do also have a CLI. It's fairly exhaustive that allows access to all of the, well, obviously to all of the CRUD stuff, as well as to all of the watches and lists and filters. So we have options to be able to compose in filters, in set, out of set, equals, not equals, the relation filters and stuff like that. So these are just some examples. Now the CLI usage is under onos-topo, especially the query is then get, and the get then has sub branches for entities, relations, kinds, but we also have get objects, and it's kind of almost like an alias because some of the, especially like the relations, depending on how you specify the scope, the relation will actually be a grab bag of things. It will, because it may be both entities and relations received at the same time. And also you can do onos-topo get objects and you'll get all of them. Not necessarily recommended for scalability purposes, but you can. So there's clearly going to be overlap between those different usages. And support the same options, and just the output will look slightly different because you've asked for objects and the uniformity of output may be different.
So I was not aware that you could do filters on the command line.
Yes, you can.
This is really cool. When I wrote those first few smoke tests, what I did was I actually have this Python code that stitches everything back together. I don't need to do that. I can just do it this way.
Yeah, you can definitely do things. And we also support verbose option, clearly for the lists and for the gets themselves too. So you're going to basically get a fairly concise option, but then if you specify verbose, all of the aspects, values will be shown as well, provided as a JSON, one per line, that you can then extract if you wanted to for scripting purposes and rehydrate them into Python, map. I think that's it. That's the conclusion of the overview.
Thomas, something that often comes up is how do we create topo entities at the command line? And well, I put a few of them together. I pasted them into the chat there, but they didn't come out with the line breaks. Maybe it's something we can add to this slide as well. But you know,
that's definitely a great idea. Yeah.
Yep.
Let's take a look at the chat here on the screen.
The line breaks didn't come out, but I can.
That's fine. I will. Yeah, that's a great point. I will add that for the to the presentation as an
example. That stuff is super handy for just little knockoff tests. It's really very helpful.
And so you can see, I think the aspects, you know, they're a little bit maybe on the CLI, they're a little bit maybe unwieldy, but I think in general, you should be able to recognize the power of it in the sense that we can attach arbitrary pieces of information in it. Now, since this is in JSON, the idea is then in future we'll be able to also then provide schema validation. Using JSON schema, and then we'll have to probably figure out how we want the rule language to be specified for must adhere to schema, or you know, or figure out what because we could for example go entirely strict that no additional information but anything that's in schema must be basically everything, only things that are in schema can be added, right? Or you can say, you know, this must be the minimum set of things provided for these kinds of entities. Otherwise, you know, they can be created. But then you can also add other stuff if you want. So there can be probably levels of strictness that we want to add. Because clearly, the more kind of ad hoc it is, the more flexible it is, but also more of a pain it becomes as you migrate things and as you want to evolve the schema. Then you don't have a very disciplined way of moving forward or even translating, because you might want to, for example, out of the schema and then have an automatic migration applied to it, right? And if you don't have solid schema in place, then that's going to be difficult. This is something that Jeff Mogul was warning of pretty vehemently. So it's something that they ran into and was a big pain for them.
So I wanted to ask a little bit about just when it's appropriate to use onos-topo and when it's appropriate to use something else. So for example, in Ether, we modeled everything as, you know, Yang models within onos config. I could imagine where we could have taken out sites and enterprises, for example, and modeled them in onos-topo. And then, I mean, you could even pull out other objects and model them in onos-topo. Why? What is sort of, maybe one way to ask it is, why did you model these E2 nodes and E2 cells in onos-topo instead of doing our approach where we put them in Yang models, we wrote an adapter,
they kind of exist. Well, it's a philosophical question, right? But we model them this way because that's how they exist. They're separate entities existing independently in the real world, or pretty much independently of one another. Right. I mean, and if there's relations between them, those relations are reasonably optional in a sense. You know, the fact you can install a cell, and then you can install a CU, and then you can say, you know, this CU manages this cell. They're not like hardwired together or put in a container or anything like that. So they exist in their own right, and so whether you configure them or not, they sort of an existence and persistence of their own. So to me, that would be more applicable to putting in a real topology. Sorry, Jordan, you were going to say something.
Yeah, I mean, what we do in E2T is there's like an entity for each of the E2T nodes, and then an entity for the E2 nodes, which are the network devices. And then basically connections, like the E2 nodes connect to E2T. And when they connect to E2T, we create a relation between the E2T node and the E2 node. And we use that basically to track connections, like southbound connections that are actually active, and use that in turn to like do mastership election and things like that. And so I think it's like the relations between the entities that makes it really powerful. And so I think if objects have those kinds of relations that need to be managed, then it's a great API, and the aspects have been awesome.
You could, I'm just thinking now, based on what you mentioned, Scott, you could do something like RBAC,
Yeah, that was one of the things I had in mind was the RBAC that Sean is going to add.
Yeah, you could do users and groups and roles and all that stuff. Yeah, okay. But you wouldn't have the nice, I guess the way you guys are doing it now, you have if you like YAML, you have the YAML as a sort of concise way to describe all this stuff. Whereas if you were to do it with Topo, you'd have to write gRPC for all that. You'd have to map out all those objects in Proto.
Well, the aspects have to be their Proto, right?
Right. Okay.
Yeah.
Yeah. So Sean, what is the criteria you would use on choosing to implement the RBAC in onos config via Yang versus in onos-topo as entities and relations?
Yeah, I guess the thing with onos config is, well, you have a formal modeling language with the Yang, and then you have the history as well, as you can see who made what change, and potentially roll back on it as well if we had to roll back completely implemented. So I think I would think topo is a good way to represent a live topology, like you had, we'll say, with SDN and onos classic. You were talking about a controller controlling something, and I think it's the same in SDRAN. The E2 nodes are part of the topology. They're part of the running network. So really, I don't think RBAC really is something that I would put on onos-topo. It's not representing a physical topology of anything. But I do see a point with the sites, Scott. I mean, that is more probably closer in my mind to what onos-topo is meant to represent.
Yeah. I mean, we could go sites, then we could go, enode Bs within sites, their devices within sites. It seems to me like we cause ourselves some pain if we went to do that, because we'd have sort of divergence of API and mechanism. The GUI, you want to add an enode B, it needs to know to call a topo API. You want to add IMSI to a device group, it needs to call an onos config API. So I guess I'm trying to see why would we inflict pain on ourselves by having two interfaces, unless I'm getting something out of this interface that's more powerful than what I'm getting out of the onos config interface.
Well, I think in a way we kind of have we're hiding the pain a little bit in onos config, because really onos config, while you configure your sites in there, it's not the single source of truth of whether a site exists or doesn't. I mean, that really is probably in Netbox,
right?
And then maybe you could synchronize from Netbox over to onos-topo. And onos config or something. I'm not really sure how to manage it.
Yeah, and also might allow you to keep the configurations to the different entities smaller, right, and more targeted.
Yeah, more granular. Yeah.
Exactly, because the trees would get smaller, right?
Yeah. So I mean, the thing is like something like site. We can have a history of who created the site and so on like that, but it's not the single source of truth of when the site was created. Really, it's just a reflection of it. Mm-hmm. And so that's kind of why I think that something like that would be more suited to topo. And then like you said, the sub configuration beneath that site then might be something that's more suitable to keep in onos config, because that's really the source of truth as to whether a site is a particular maximum bitrate set or I'm trying to think of examples now, but yeah, the sub configuration of the site would be kept in onos config then.
But one of the issues is that if we go that route, we do have, as I think Ray or Thomas said, multiple trees, smaller trees, but multiple trees. So if each site had its own config tree and someone asks us to come along in the future and model a device that can roam between sites, now we end up with trees potentially pointing to each other, or even if we have an application Applications could conceivably span sites because an application could be on the cloud, and you want to have two sites pointing at an application that they share.
Yeah, so at the moment, we're using leafrefs to define those relationships between sites and various other things, and those leafrefs can't cross a model boundary in onos config. Now, based on what you were saying last week, Scott, I think we might have to start thinking about some kind of a super leafref or something like this, that can act in onos config as a way of crossing boundaries between models and between configuration trees.
Yeah, an external leafref or something.
Foreign key thing, right? Basically.
Yeah, exactly. Yeah, whether you define it in Yang or whether you extend Yang or something to define it, that's to be decided. But I'm getting the feeling that kind of thing there is a demand for it.
And the other thing that strikes me a little bit, I'm curious, all of this onos-topo, if you'd wanted to model it, you could have modeled the onos-topo service inside of onos config. Does that make sense? I mean, you could have Yang models for relation, Yang model for entity, Yang models for aspects, if you'd wanted to do it that way. Leafrefs, to hook things together.
I suppose you could, but I don't think it would really fit the model, the update model, and
right.
It would be more operational. If anything, it would have to be reflected as an operational state, right? Because the topology can change. The whole idea is for the topology to reflect what is, rather than the other way around.
Okay, so that's interesting. So you're saying that there is something coming in and moving these things around potentially, rather than it dictated in a top-down manner, but maybe in a bottom-up manner.
But remember, the topology, it could be both, because the topology is it's multi-abstract, it becomes multi-layer topology, right? In the sense that we could sketch out a planet topology, and basically have it be kind of its own island. Then we could map out a topology of how it's actually going to be deployed. A schema kind of for how deployment, and then you could map it out to an actual site, how it's actually the actual instances of things. So there could be multiple different layers of this stuff, and they could all be related, and you could have links, not just within the layer, but links across the layers.
And I think if you look at the MALT paper, so they are using for modeling of the data centers and enterprises, and so it's a hierarchy of things from the sites down to the devices and ports and all of that. So we can easily model enterprises sites and connect them together in the topology.
Yeah, one thing that we're not doing that like the MALT paper does, they have these shards where basically they can have different autonomy for the different shards of the topology. For us, it's just one big collection, because the idea was that we were going to be limiting it more to a certain scope of use. Because they literally have one topology repo that has these shards, and that's how they segment it. But otherwise, it's still one view. We won't have that, right? We will have multiple instances of those things.
So a good use for the topology in the Ether context would be to have a list of sites with their inode B related to them and the device moving from one to them. So it's easier to identify.
Or network captured there as well. Stuff like that.
And you would have to think that would overlap nicely with SD-RAN.
Exactly. Yes. Right.
And technically, those E2 nodes, since they will be discovered by SD-RAN, so even if we create them via operator, technically the IDs should be consistent. with whatever the whatever E2 node reports part of its setup request connecting to the rig controller.
Yeah, so to answer your question, Scott, I don't think that would really fit the update model and kind of the usage model of onos-config.
Sure. Yeah, that's helping me understand the differences between them.
Yeah.
Yeah, I guess the thing for Sean and I to decide is, you know, whether we do want to go to a model where we have sites as entities and enterprise as an entity and relations between.
Yeah, you might still need to have them both places, because onos-config seems to be the place where you model the configuration for a single site, while onos-topo is where you know how that site is connected to other sites, if it is, and which kind of devices belong to that site.
Yeah. Yeah, I'm just thinking, you know, once, you know, we go to move enterprise and site into topo, and then the next thing we say, well, we should move enode Bs into topo as well. I think that would be a logical step.
I don't think you move them. I think you display their status.
Them,
yeah, but it's not like they're not in onos-config anymore.
Right.
So they're not moved, they are duplicated, because it seems like onos-config is more top-down and onos-topo is more bottom-up.
To a degree,
yeah. Onos-topo really, I think, defines or reflects the physical in my view.
And do we have any other objects? So it's really just enterprise, site, and enode B that are our physical devices. I mean, I imagine someone could add for us a fabric switch as a device or something, and we could represent it this way. But
do we have a modeling of the UEs in?
For SD-RAN has its own separate subsystem for UEs. It's called UENIB. It's actually very similar to Topo, but except it doesn't have the consistent update semantics, but it does have the same aspect model. And it's literally just an ID with a set of aspects. There's not even a revision, that there's no other pieces of information. It's a flat list of inventory of devices with their aspects. So the application is basically a repository for X apps to be able to attach information about the UEs.
Yeah, we're gonna need a presentation on that as well, because we've been talking a little bit about that, about possibly leveraging that. Right now in either, we do not represent either SIM cards or devices as first-class objects. We have device group, and inside of device group you list a bunch of IMSIs, but you know, sort of device group is the first class object.
Let me put one together. I can probably do one fairly quickly. I can do one next week at the same time, you know, not the same time, that's around the time where Jordan, you're gonna give one on the atomics, right, when you're here next week?
Yeah, and I was wondering if we need to do onos-config and atomics. I mean, like as far as the internals of onos-config.
Yeah.
Oh yeah.
Yeah,
I need that desperately.
Controllers and all this.
We should make a few of these.
For sure. Now, those were really good questions. Now we're at the top of the hour. Just a couple of things to at least sum up. One thing is Adib noticed that our CLI examples actually use the old style IDs. And that's also one thing that I completely forgot from the overview, is talking about the convention for IDs. Even though they're defined as strings, we have convention to use basically, just like for Monos Classic, we use URIs we are using URIs here. So for example, all of the SD-RAN entities have E2, for example, like E2, you know, so we can differentiate between, and we actually, the E2 scheme part is then what defines kind of how we represent the rest of it. And so let's say in SD-RAN, we have the node ID, which is without the PLMN ID and everything, and which is either basically the GMB, and it's the NCI or ECI. But then we also can have the cell information for cells. Anyway, the point is that it's URIs, and then that allows basically kind of the managing, first of all, the collision space on the different types of objects provided by different realms of the topology. So I'll need to add a section on that, update the examples with the CLI with that new data, because this was actually taken from the Git docs. Also probably need to add the examples that Sean suggested to show how to create things. And I'll add some concrete examples of different, how we use it, let's say in SDRAM, to be able to show actually graph of the entities and relations so people can visualize how it's used better.
Yeah, that all sounds great.
Yeah. Okay, and I'll prepare for next week. I'll prepare UE nib as well.
Mm-hmm.
For the onos config, I will probably need some help from either Sean, Adib, or Jordan. I mean, I can start with that, but I'm not as intimately familiar with the onos config internals to be able to do a fair job. And also, we need to keep in mind that things will be changing a little bit internally.
Yep.
Yeah.
Yeah.
All right.
Can you just schedule these three?
I will schedule those meetings. Yeah. Will you be here first thing Monday or?
Yeah, I'm coming on Sunday.
Okay. You're coming on Sunday. Okay, so I'll probably just schedule one a day, maybe Monday through Wednesday.
Okay.
Is that all right? Is Tuesday okay for you? I can be ready with the UE init for Monday.
Yeah.
Will Tuesday be okay for you for the atomic stuff?
Yeah. We should maybe do
the
config and atomics. Yeah. On Wednesday.
Okay. So Tuesday. So UE init on Monday, config on Tuesday, and then Wednesday we'll do the atomic.
Okay.
Great. Anyway, I guess you guys are past the end of the hour already. So is there any other questions?
I didn't see a link to these slides in the meeting invite.
I'm gonna add the link to the invite, and we'll send it to you guys.
Great, thanks.
All right. Well, thank you, everybody.
Thank you.
Questions? We'll see you next week.
Thanks. Bye.
Yeah, bye all.
Bye. Bye.
And I definitely, I don't know when we're going to get to it, but I still want that CLI